So this video is going to be on carboxylic acid and esters. So these are, again, two different types of organic compounds that we're going to need to know how to name and draw. We're going to practice naming in this video, and then we'll do practice for drawing in class tomorrow. So for carboxylic acid, the functional groups, the functional group looks like this. You've got a carbon, and it's double bonded to an oxygen. So just like we saw in our aldehydes and ketone video, we've got this particular carbon double bond with the oxygen. But in a carboxylic acid, that carbon is attached to an oxygen, which is bonded to a hydrogen, right? So this carbon is bonded to this oxygen, which happens to be bonded to this hydrogen. And this carbon here on the other side could be bonded to another carbon group or a hydrogen or whatever. So right now I'm just going to put that as an R, just to show that it could be any group there. So anytime you see this functional group, you know we're looking at a carboxylic acid. For here, we're looking at an ester. So an ester is similar in that we've got a carbon double bonded to an oxygen, and that carbon is also bonded to another oxygen. So similar to our alcohol and ether, the relationship between carboxylic acid and ester are very similar. So we've got the carboxylic acid here. Again, this R could mean that it is another carbon group or another carbon chain or a hydrogen or whatever. But on this side, this oxygen is not bonded to a hydrogen, but rather it's bonded to another carbon group. So when I say R here, it could mean any sort of carbon chain. So any carbon chain. So when we see this sort of setup, we're looking at an ester. If we're looking at this, we're looking at a carboxylic acid. So let's learn about naming these. So right here, I've got a 1 carbon carboxylic acid. So when I'm naming carboxylic acids, I want to include my alkane name. So with 1 carbon, we're looking at methane. But then I'm going to remove the E, as we usually do, and I'm going to add the ending of oic acid. So this would be methanoic acid. And it is 2 words, so you're going to leave a space between that and the acid. So the ending oic acid is indicative of a carboxylic acid. Okay, so that was our first example. I just look at the number of the carbons, and then name the alkane name, remove the E, and add oic acid. Because carboxylic acids are always going to be on an end, they're always on the end of a chain, we don't have to specify the number of it because it's always going to be carbon number 1. Okay, our next example, oops, I think that's in the way. Let me just erase that. Our next example has a slightly more complicated structure, and we're going to name it just like we usually do, starting with identifying our longest continuous carbon chain. So I want to give my carboxylic acid priority, and what I mean by that is that I want to give it the lowest possible number. So the carbon that the carboxylic acid is on is going to be carbon number 1, and then carbon number 2, 3, 4, 5, 6, 7. So I've got hept as my prefix, right? If it's an alkane name, it would be heptane. But we want to get rid of that E and add our carboxylic acid ending. And our carboxylic acid ending is heptanoic acid. Now to this, I want to specify, because we've got a few things here that do not fall into our longest continuous carbon chain. So we've got a few side groups here. So I've got this 1 carbon here, so that's 4-methyl. And I've got 2 carbons here, so that's 5-ethyl. So with that, I'm going to put that all together as 5-ethyl, 4-methyl heptanoic acid. There is a dash there, just want to make that clear. So that would be how you would name this. Really, the only difference is the ending here, heptanoic acid, to show that this is a carboxylic acid, and giving it priority. So that's going to have the lowest possible number, that particular carbon. Now let's take a look at an example if you've got 2 carboxylic acids, which we honestly won't see all that much, but you should be able to name this. So if you have 2 carboxylic acids, obviously they're on either end of this carbon chain. I'm going to number them. So 1, 2, 3, 4, 5, 6, right? And instead of having just one oic acid, what I'm going to do is include a prefix to show that there's 2 of it. So because there's 6, I'm going to go hexane. And then I'm going to get rid of the E. But then because I have dioic acid, I'm going to keep that E there. So remember that rule about 2 consonants together. So if there's 2 consonants right next to each other, I need to make sure that there's a vowel. Usually it's A, but in this case, because I already have hexane, I'm just going to add the dioic acid to make it to show that there's 2 of those carboxylic acids. Again, I don't have to specify the number because if I have 2 carboxylic acids, that means they're going to be on either end of the molecule, right? And I can't have more than 2 in one molecule, at least not that we're going to see in this course. Okay, we're going to go ahead and name some of our esters here. So we want to start off with the carbon that has the double bonded O. So the structure of this, like I showed you at the beginning on the first slide, you've got a carbon double bonded to an oxygen, and that carbon is also attached to the to another oxygen. Wherever that carbon is, I want to give that a number 1, and number 2, number 3. I'm going to number away from there. That's going to be what I call my parent chain. So whatever one that C double bond O is starting at, that's going to be my parent chain. So because this is propane, so I'm going to write propane here, and then I'm going to show you what I'm going to change the ending to. For esters, we're going to use the ending of O8. So it would be propan O8. Again, so each ending tells you what we're looking at. So previously when we looked at oic acid, we're looking at a carboxylic acid. If we're looking at al, we're looking at an aldehyde. If it's one, we're looking at a ketone. So again, depends on the situation, right? And now on this side, I'm just going to use this as a side group. So pretend that this whole thing is a side group. So I'm going to do 1, 2, 3, 4, 5. So it's going to be pentanoate, and I want to leave a space between these 2 words, and that is important because that is only for esters. And another thing I want to bring your attention to, even though this side is technically longer in terms of carbon chains, I want this to be my parent chain, because whichever one that has the C double bonded O to it, that's going to be the parent name. So that's going to be the one that has the ending of O8. Everything else that's on the other side is just going to be a side group, or named as if it was a side group. I'm going to do the same thing here. Start with 1 and 2. So here there's 2 carbons there. So that's going to be ethano8. And if you take a look here, this is quite a long chain, and it also has a bunch of side groups on it. So let's start with our longest chain. Again, I want whichever carbon the oxygen is attached to, that's going to be carbon number 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be non-nil. And I want to leave that space. I'm going to leave some space there. And let's take a look at what our side groups are. They're all methyl groups, right? So I have 2, 3, 6, 7 tetramethyl. So 2, 3, 6, 7 tetramethyl nonyl. And that would be, and ethanoate. So 2, 3, 6, 7 tetramethyl nonyl ethanoate. So anything that comes first in ester naming happens to be on the side that the oxygen, this one oxygen, is attached to. and then the parent name happens to come from the side that the C double bond O is attached to. Okay, so that's how you would name carboxylic acids and esters.